Okay, this is going to be your trig lesson for today. We're going to look at the trig identities from chapter 5, section 1. There will be a lot more examples in that section if you want to take a look at those. These are many of the identities that you've already seen, and we have additional ones that you can see here that we call the Pythagorean identities, but everything else is pretty much the same that you've seen before. So what we're going to do is we're just going to go through a couple of these and fill in some notes, and then I'm going to do some examples, and then I'll give you your assignment. So for this first set, we just want to look at what does the tangent of theta equal. It equals a couple different things. It can be 1 over the cotangent, or it can be the sine over the cosine. Again, these are coming straight from your identities that are written above, and it will be important for you to know how to use them as we move forward. Then the cotangent would be 1 over the tangent because those two are reciprocal functions. And then that would be cosine over sine. Again, because they are reciprocals of each other. When we look at the cosecant, we know that the cosecant is the reciprocal of the sine. So if we make this one 1 over the sine, then we're going to see the same results. And if we make secant 1 over the cosine, then we will see that those are reciprocals as well. When you use your calculator to evaluate these cosecant, secant, and cotangent, you will have to do 1 divided by the sine, 1 divided by the cosine, and 1 divided by the tangent to be able to evaluate those in your calculator. The Pythagorean identity for cosine is if we take the Pythagorean identity from above, that is sine squared plus cosine squared equals 1. It's like the Pythagorean theorem, and therefore we call it the Pythagorean identity. If we solve this for the cosine, we are basically subtracting the sine from each side. So the cosine squared will equal 1 minus the sine squared. If we solve it for the sine squared, then we would be subtracting the cosine from each side. So that will be sine squared equals 1 minus cosine squared. Notice that the cosine is what is squared, not the angle that you're plugging in. So oftentimes people will want to write this in another way, and I'm just going to erase what I've written here, and you can change this to be, instead of having the square on the inside, we can rewrite this and put sine of theta squared and cosine of theta squared. So it's the actual value of sine of theta and the value of cosine of theta that you're squaring, not the theta that's being plugged in. You could do the same for this one above if you would choose to write it that way. So for our next piece, we're looking at the Pythagorean identity, and if we divide everything by the cosine of theta, what happens there? So if I take everything here and divide it by cosine squared, then the results will be that for the first part I get 1 because cosine divided by cosine squared is 1. And then I will get sine squared divided by cosine from the second part. And we know from above that if we have sine over cosine, that is tangent. So then what we end up with here is a tangent squared. Because we have sine squared over cosine squared, that will make that be tangent squared, and then that is equal to 1 over cosine squared. And up here we have 1 over cosine is secant, so if we're going to square that, then that becomes secant squared. Again, it's because it's 1 over cosine, but it is 1 over cosine squared, and that makes it secant, but secant squared. If we solve the equation for tangent, then we would subtract 1 from both sides here, and the result would be that tangent squared theta equals secant squared theta minus 1. Again, that's just one of our identities that we have above and that we've solved it for something different. when we look through that information. We can also divide everything by sine squared, and that's going to result in another one of our Pythagorean identities. Again, sine squared divided by cosine squared. Up here is tangent, but here we have cosine over sine squared. If we go back up to the top, cosine over sine is cotangent. So we get a cotangent squared theta. If we take sine squared divided by sine squared, that will be plus 1. And if we take 1 divided by sine squared, 1 over sine is cosecant, and since it is squared, then that makes it cosecant squared. If we were to solve the resulting equation for cotangent squared, we could subtract 1 from both sides, and that would get us to have the value of cotangent squared equals cosecant squared theta minus 1. Again, that's an identity that we have above, and you will see that the Pythagorean identities work in this way where we can solve for what we need to. All right, so we're going to move on to the next part of this, and we can move this just a bit. Some other identities, sine of theta, we could write that as a reciprocal of cosecant, so 1 over the cosecant of theta. We have cosine, that is 1 over the secant of theta. Again, they're reciprocals. And then tangent would be 1 over cotangent as a reciprocal function. So all of these are listed again in the chart. You're going to want to make sure that you practice with these and how they can change. We can have a negative in front of them where we wouldn't have had it above. So lots of things we can do. However, what we really need to do with this is we're going to use these trig identities to write each expression in terms of a single trig identity or a constant. So sometimes it'll be a single number, sometimes it'll be a new trig function. So we're going to use what we know about these. So if the tangent of theta is equal to something that relates to the cosine of theta, then what I would do is I would write the sine of theta over the cosine theta as a substitution for the tangent of theta. Then I'm still going to multiply by the cosine of theta, and when I do that, that's over 1, and I can imagine that those two are going to divide out. And once they divide out, then the answer that I get is the sine of theta. So the answer to that multiplication of those two trig functions is the sine of theta, because this part and this part, cosine and cosine, cancel each other out, leaving you with sine of theta over 1. So we're just employing those formulas that you see in the box above. All right. This one, we know there's a cosine squared on the bottom. I can do multiple things with this, but I think the fastest that I would see is that 1 minus cosine squared from up here. 1 minus cosine squared is sine squared. So I have sine squared over cosine squared. So this piece again changes and becomes something else. And then if I have a sine over a cosine is tangent right here. And if it is squared, then it becomes tangent squared. So that would be my solution to that equation. I'm going to do something similar on this other side. Cosine is just normal. Most of the time we try to get things in terms of a sine or a cosine because those are the most basic functions. Everything else follows in line with those functions. So here I'm going to change cosecant because it's the one that is not a sine or a cosine. I'm going to keep the cosine the same, and I'm going to change cosecant to 1 over sine and put that over a 1. If I multiply straight across, then I get cosine of theta over sine of theta. And from up in my chart, if I have cosine over sine, then that is cotangent of theta. So that one will simplify to be that single function. And they can get a little more complicated, and my main goal is to simplify them as much as I can, changing things that are built off of multiple things. So I'm going to change the secant, and I'm going to change the tangent this time into terms of sines and cosines. So I have sine of theta times 1 over cosine of theta over tangent. But I'm actually then not going to change the bottom one, because what I realize is that the numerator, this part, when I multiply those together, I get sine over cosine. And sine over cosine is equal to tangent. And then my resulting function is tangent over tangent. And tangent over tangent equals 1. So end up with that for my value that I have. So what you're going to find is that you're going to have to do a little bit of work to make these simplify and move into what you want them to. There's a few more practice ones here, and this is what your assignment is going to be tonight. I would like for you to just finish these 4, and then I'm going to come back tomorrow and do another video that's going to have you do a bit more complex questions. I'm just going to give you a glimpse. They do have a little bit more complicated issues with factoring and that kind of stuff. So for tonight, your assignment will be this page right here. And I'm going to leave this up. You can take a screenshot. I'm also going to post this on the Unified Classroom so that you can work on those questions. Have a good day.